Well, hi there, boys and girls. Today we're going to learn the product rule. So let me show you what this looks like. Let's just say I've got some function, h of x, that is defined as the product of two other functions, f and g. And let's say for some reason I'm lazy and I really don't want to multiply f and g together to get this big long thing. Or it might be that it's impossible for me to multiply f and g together. So here is the rule to find the derivative whenever you have two things being multiplied together. And that rule looks like this. It is the first function times the derivative of the second function. And this is our notation for the derivative of the second function, g prime of x, plus the second function times the derivative of the first. And so this is how we are going to be able to find what's called the derivative of a product, or the product rule. Let's go take a look at two applications of this. So here we go. I've got this function that's got, look at that. I got 4 terms in that polynomial, and I've got 3 terms in this polynomial. So I really am not interested in multiplying all of this together and then finding the derivative and then plugging in 1, because that would take me a long time to do. This times this, 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 la 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 la. It's too much. So we're going to take advantage of the product rule. So I've got two functions here. 2x cubed plus 5x squared minus 7x plus 4. I'll basically call that f. And then 4x squared minus 5x plus 2, I'll call that g. So here's how the product rule would work. The derivative would be the first function, 2x cubed plus 5x squared minus 7x plus 4, times the derivative of the second. Now the derivative of the second, with our power rule, we know that's 8x minus 5. And then plus the second function times the derivative of the first. And the derivative of the first function would be 6x squared plus 10x minus 7. So that's the derivative without having to multiply all of that out, which would take me forever and I'd cry. So now we're going to plug in 1, and let's see what our answer is going to be. So if I plug in 1 for all those x's, I'm going to get 2 plus 5 minus 7 plus 4 times 8 minus 5 plus 4 minus 5 plus 2 times 6 plus 10 minus 7. Alright, so let's see what that would be. 2 plus 5 is 7, minus 7 is 0, plus 4 is 4, times 3, plus 4 minus 5, negative 1, plus 2 is 1, times 16 minus 7 is 9. So I get 12 plus 9, and I get 21. Where is that? Right there. So that's an application or an example of the product rule when you really don't feel like multiplying all this stuff out. Now, if you wanted to multiply all that stuff out, then you don't have to worry about the product rule. All right, let's go to the next example. And the next example is I've got some function a that's the product of f and g, and I have to find a prime at 4. And I don't have any information about a over here. And I'm supposed to find the derivative of a at 4. So here I'm forced to use the product rule. So let's find out what a prime is. A prime is the first function times the derivative of the second plus the second function times the derivative of the first. And we want to find a prime at 4. So that's going to be f of 4 times g prime of 4 plus g of 4 times f prime of 4. So let's see if we can get that information from this table. So a prime of 4 is, let's see, f of 4 is 14. G prime of 4 is 4. G of 4 is negative 3. And f prime of 4 is 9. So that's going to be, that's a 9 by the way, 14 times 4 is 56, yes, minus 27, so what is that? It's almost 30, it's 29. And so there's our answer, and there you have it. Alright, so let's go ahead and get after this quotient rule. And the quotient rule is how to find the derivative if you have a function that is the quotient of two other functions. And let's just say you don't want to divide the two functions by doing the long division or synthetic division, or maybe you can't even divide them anyway. This is how we're going to find the derivative, and it's just another formula. So h prime of x is going to be the bottom g of x times the derivative of the top, that's f prime, minus the top times the derivative of the bottom, and this is all over the bottom squared. So we're just going to call that g of x squared. And it's not the derivative on the bottom, it's just g of x squared. And I've got a little ditty that goes along with this to help you remember. I'm going to refer to the top function f as the high function and the bottom function g as the low function. And if I say d, I mean derivative. So listen to this. It's not really a rap song because I don't like rap that much anyway. The only kind of rap I like is gift rap. So we're going to call it a ditty. Here's the ditty. It is low d high minus high d low over low low down below. And Carlos just walked in, so he's probably coming in here to see if we have a video tonight. Or no, he's actually dropping off his backpack. You want to say hi, Carlos?
Hey!
Okay, that was Carlos. So let's take a look at this again. It's low d high minus high d low over low low down below. So that's how you remember that. Anyway, if you don't like that at all or you think that's silly, it doesn't matter. So let's go take a look at a couple of examples here. Here I've got a function a that is a quotient of f and g, and I want to find a prime at 4. So let's go ahead and do the formula. The formula is g f prime, low d high, minus high d low, f g prime, all over g squared. This is how I find the derivative of that quotient. So let's see if we can't plug them in. We want to evaluate all these at 4, so we're going to look at this row right here. So g of 4 is negative 3 times f prime of 4 is 9 minus, and then f of 4 is 14 times g prime of 4 is 4, all over the bottom squared. Negative 3 squared, of course, is positive 9. So let's scoot on down here and see what this is. Negative 3 times 9, that's negative 27. 14 times 4 is 56, all over 9. So that is negative 83 over 9. And so our answer is E. All right, let's take a look at another example where we've got a function divided by another function. Again, you could do long division here and try and work it out, but it's not going to be any fun. So let's just go ahead and do the derivative. The derivative is low d high, so it's the bottom function times the derivative of the top. The derivative of 2x is 2, so there's low d high, minus the top times the derivative of the bottom, and this is all over the bottom squared. Let's write it like that. So let's see if we can do some algebra here. Distribute our 2, we get 2 minus 6x squared, and then this is going to be plus 12x squared. Notice those two negatives made a positive, all over 1 minus 3x squared squared. And this simplifies to 6x squared plus 2 over 1 minus 3x squared squared. And so it looks like that answer is C.